Let us learn stop and chop technique of phacoemulsification. After capsulorhexis and hydrodissection, the phaco needle goes in and some superficial cortical lens matter is removed. And now the setting is in the scalped mode, which means vacuum is low from 50 to 100, flow rate is 20 to 25, and ultrasonic energy is according to the hardness of the nucleus. And we must remember that we must sculpt and go forward. We must use ultrasonic energy, sculpt the matter, emulsify the matter in front, create a vacuum in front, and then go forward. Otherwise, we will just push the nucleus. So we have to use ultrasonic energy, use some vacuum to aspirate the emulsified matter, and then create a space in front and then go forward. Otherwise, we will just push the nucleus. So this is the first case. In this video, we are going to see two surgeries, two nucleus managements by the stop and chop technique. The first one is almost done. In this case, in this first one, we have emulsified the first first heminucleus completely, and then we have come to the other heminucleus. But for the beginners, I suggest that you emulsify only one piece of a heminucleus and then go to the other heminucleus, divide the other heminucleus, and then emulsify the pieces. Let us see another case. The capsulorhexis has been done. Now this is hydrodissection. As soon as the fluid wave goes to the opposite equator, stop injecting fluid, depress the nucleus, and now you have to rotate this nucleus. You can rotate single-handedly, but jonular stress becomes less if you rotate the nucleus bimanually. And now we're going to manage this nucleus by stop and chop technique. See these steps. The phaco needle goes in with its bevel down. Some superficial cortical lens matter is removed. Now the handpiece is turned to make the bevel up, and now we are going to start sculpting. As I said, we must use ultrasonic energy and some vacuum to emulsify and aspirate the matter in front and then go forward. We must not push the nucleus. Ultrasonic energy is used only when we go forward, and as we reach to the distal end, we stop, be in irrigation, and come back. So done. Just by 3-4 sculpts, we can reach sufficient depth if we engage the tip in such a way that we are sculpting some lens matter. And now here it is. We divide the nucleus into two heminuclei, and now the setting is in holding mode, where vacuum is about 300 to 400, flow rate is 30 to 40, and ultrasonic energy is again according to the hardness of this nucleus. In this case, it is set at 60%. Whatever be the setting, since the ultrasound is in linear mode, you can control the foot switch to get adequate amount of energy. If the nucleus is hard, you press little more to get more ultrasonic energy. If the matter in front is soft, use less ultrasonic energy. And this is the last but on piece, and this is the final nuclear piece. At this time, what I usually do nowadays is remove the epinuclear shell from the nucleus and then emulsify the nuclear piece. In this case, this nuclear, small nuclear piece is lost at the anterior chamber angle. So what we do is inject some more visco, and bring the piece at the center, visco all around, and we go in the anterior chamber again with the handpiece and emulsify this nuclear piece. Sometimes this nuclear piece may be very small and it may come out through the main wound. Please learn stop and chop technique. It's a beautiful technique for the beginners. Thank you very much for your attention.